All right, here's 1, 2. Again, I told you in chapter 1A, the focus would really be linear. You'll see that today. We're going to do some solving. It's going to be a big part of the learning objective. We'll solve. We're going to get some intercepts too. It says at the bottom to create mathematical models. Hang on to that for a bit. Hang on to that. That's really a 1-3 topic. We'll get there. Okay? No, modeling gets into some pretty good word problems, and we're still kind of brushing up on some algebra skills here, kind of building up to 1-3. Anyway, let's solve. Let's do some solving. Alrighty. 3x minus 6 equals 0. So everything today will be linear. I know I kind of told you that in 1.1 and then kind of threw some quadratic stuff at you. I promise. Won't happen today. Pretty simple one to get started. Add 6. Divide by 3. That's where your canceling would happen. And there you go. Right? That's a really typical linear equation. Like, basically, I have it set equal to 0. So I put in a y value, and then I solve to get x. And you'll see a lot of times if the equation is in a nice form, like slope-intercept form, it should just take you 2 steps, right? Add 6, divide by 3. Boom, there we go. If you throw in like fractions and whatnot, and maybe like not the desired form of a linear equation, if it's in like standard form, which we'll get to, it might take like a 3rd step or something like that. But they're not too terrible. This is just a line set equal to another line. Take the approach to get your x's paired up. Those need to go on one side. So this would give us 2x. As long as you write out your work and show your steps, if you feel confident kind of doing 2 steps at once, I don't think that's terrible. You could do that. Right, so it gets 2x equals negative 12. Right, this one was a little more complicated, that it was set equal to.
If Jenny Springmeyer is in the building, will you please report to room 100? Thank you.
Little announcement there if you heard that. Sorry about that. Alrighty, divide by 2, right? So again, this side right here, it's another equation, it's not a constant, whereas over here it was just set equal to 0. So there's a little more going on, took a 3rd step, no biggie. X is negative 6, right? We talked about like a point being a solution. So remember now, I'm not gonna do it just for the sake of time, but if you go plug negative 6 back in for X on both sides, and not a bad idea to run through, to even just pause now and do it. To convince yourself that, yeah, like negative 6 is a solution to this equation. Both sides need to simplify to the same number, okay? And from looking at it, I think you're going to get negative 24 on the left and on the right. All right, here's a little bit of a step up. A couple big league problems here. First thing I'm going to do, right? I still just have 2 lines. It's just they've got stuff going on. The big key that would tell you that they're linear is there's no exponents higher than 1. There's no x squared. There's no x to the 3rd, right? So even if like the equations do look a little bit more complicated, if you don't see anything other than like your x variable to the 1st power, which means there's really no exponent written on it, it's linear. All right, I'm going to distribute the 6. So I get 6x minus 6 plus 4. Distribute the 3, 21x plus 3, okay? If you're getting good at these and feeling confident, this is kind of a universal thing for these pre-recorded lessons. Throw it on pause, right? Throw it on pause, maybe even throw it on mute, and you kind of hit the pause button step by step and see if you can beat me to the solution. It's a great way, if you're feeling confident, to kind of work ahead one problem, then hit resume, okay? Unmute it, see or hear what I'm talking through, and see if our work matches, okay? All right, next thing is I'm going to deal with the constants here. Well, actually not quite. I'm going to combine these two. 6x minus 2 equals 21x plus 3. I am now going to add 2. So it's getting a little bit more complicated. So what you're seeing is they're really the same steps you've seen. There's just more of them. It's got a little more going on. All right, I'm going to subtract 21x. As always, I'm taking the approach that my constant terms and my terms that have a variable, I want them split up. So I got negative 15x over here, 5 over there. All right, I'm going to divide by negative 15. Again, by the standards of a linear equation, this is a little more complicated. That reduces to negative 1/3. Okay. Don't get freaked out if you get a fraction as an answer. That's entirely possible, right? A lot of them have whole numbers as solutions, just so as you're working through the steps, the numbers work out nice. But if you get something like that, don't be stunned. All right, so this next one looks a little different, but again, those x's do not have exponents higher than the first power, right? And down on the bottom of the fractions, there's just constant. So this is really linear when you get down to it. It looks a little bit different, but there's no exponents. First thing I'm going to do is get those two fractions added together, which means I got to multiply the top and bottom of the first one by 4. Second one needs to get multiplied by 3. And we can still just have that equal to 2. All right, pause here if you need to, right, to kind of think through that step. Common denominators, right? So 3 and 4 didn't work to get those two terms added together. 12 as a common denominator, that's going to work perfectly. So you have 13x over 12 is 2. Multiply by 12. 13x equals 24. Starting to look more like what we would suspect if we had a linear equation. All right, 24 over 13 cannot be reduced. 24 and 13 do not have any factors in common. Okay. All right, let's go down to intercepts, which in 1.1, I gave you a little heads up on this, right? How to do them without a graph. Because really in 1.1, it was like, hey, just look at the graph. But then I did that thing with the quadratic. And like set it equal to 0 and solved it and whatnot. So that's kind of what's going on here. We'll work through 3 of them. The X-intercepts, just in terms of terminology, I always feel like I have to address this like right away. If you ever hear of the term the zeros of the function, you're talking about the same thing, right? Y-intercept just tends to get called the Y-intercept. But X-intercepts are sometimes called zeros. Okay, so don't get confused by that. If you're like, hey, go find the zeros of this function, go find the X-intercepts. Here's the big key, just put in for 0 for y and then go solve, right? For the Y-intercept, set x equal to 0 and then go get y. Sometimes, depending on the form of the equation, that can be really easy to do. For example, let's do the Y-intercept first over here. This one just comes out beautiful. Y equals 4, right? 0 in for x to get that Y-intercept. Y equals 1, so the intercept would be 0, 1, right? No solving to do or anything. It's really nice, okay? Really nice. X-intercept, I gotta solve a little bit because I put 0 in for y and need to get x. But to do that, I need to take away 1. I get negative 1 equals 4x. Then I'm going to divide by 4. And x equals negative 1/4, right? Which would mean that graph would go through the point negative 1/4, 0, okay? So that's like the basic gist of it. Now here's what I'm going to do, by the way. I'm going to get bold here, just so I don't want to rewrite the x, the y, and x. So in each one of these, I'm going to put a line right here, and hope that's enough space, right? We'll see. I think it will be. So now for the top, like for these next two, I'm doing the Y-intercept. Let's do those first and then do the x. Okay, the line's written in standard form, but that's no big deal. If I want the Y-intercept, I always take the approach x must be 0. X has got to be 0. 2y equals 6. Divide by 2, y equals 3, which again means that will go through the point 0, 3. Okay? For your x-intercept, 3x plus 2, y needs to be 0. Okay? Y needs to be 0. This would give us 3x equals 6. Divide by 3. And you would get x equals 2, which also means that this goes through the point 2, 0. Okay? Now you might notice a nice little theme here that I'm finding one of each. That's a theme with lines. Okay? Because you might, if you think back to 1.1 on that last problem where I actually did find the zeros using some algebra, I found 2. Right? I had to do like the factoring thing and I found 2 of them. Why is that not showing up here? It's because that function I did it for was a quadratic, right? It had an x squared term in it, which means it was possible that I could find 2 zeros, and in that case, I did find 2. Okay? With lines, that's not gonna happen, right? And you could like play around with that on scratch paper and stuff. If you draw an XY coordinate grid, and you can draw like a straight line, even use like the edge of a book or a ruler, lines can't change directions, right? They can't even change the rate that they go up or down, right? That's the whole idea of their slope. They have a constant rate of change. See if you could try to cross the X or Y intercept more than once. Spoiler alert, can't be done, right? You'll not be able to. That quadratic was able to change directions. That's where it's a totally different deal. Once you throw in that x squared, it becomes a curve, and that graph can now change from an increasing to a decreasing function. Anyway, I went too long on that. When you're dealing with lines, finding intercepts, one answer each is what you should be looking for. Y-intercept, 7 times 0 minus 8y equals negative 14. Low on space here, so I would divide by negative 8. Negative over a negative would be that. Oh, 14 over 8. Both divisible by 2. Let's call that 7 over 4. Okay. I'm going to put this up here, which means if x is 0, the y value would have to be 7 over 4. Again, I got a fraction. Big deal, right? You'll see that happen. X-intercept, 7x minus 8 times 0. Y has to become 0. 7x equals negative 14. Divide by 7, divide by 7. X is negative 2, which would tell you when x is negative 2, y is 0. That point would be on that graph. Okay, good deal. Good work. That's all for 1.2. A lot of good algebra skills with lines, right? Finding intercepts, solving, checking solution points. All right, 1.3, heads up, I'm bringing the word problems. We're getting into mathematical modeling, which adds a new element that you'll get like a written description of a situation that can be solved with a line, okay? But no, everything in that, it's not like just crazy wide open word problems. They can all be written as linear equations and solved with lines, okay? That kind of limits the possibilities of how to set the problem up, but that's what we're taking on in 1.3. Let me know if you have any questions on 1.2.